This is the jet pointed towards the sun from 3i Atlas, which is surprising because it's in the direction of the sun, whereas usually cometary tails go away from the sun.
3i Atlas should be in pieces right now. Scientists were waiting for it to break apart, and it never happened. This thing just survived forces that have destroyed every other comet that's ever tried, and yet it's still here, and it's still in one piece, and nobody can figure out why. Because that's what comets do when they get too close to the sun. They shatter, they die, but 3i Atlas didn't. And now scientists just measured something about this object that's making the alien theory a lot harder to ignore, because the way it's holding together looks less like a comet that got lucky and more like something that was designed to survive. And we only have a few months left to figure out what this thing actually is before it disappears forever. When comets die, the thing about comets is that they're not built to last. They're essentially just big chunks of frozen stuff held together by their own gravity. And when you expose them to the extreme environment of the inner solar system, bad things tend to happen. We've seen this play out over and over again. In 2013, a comet called Ison was heading toward the sun, and astronomers were excited because they thought it was going to put on a spectacular show in the night sky. It was supposed to become one of the brightest comets in decades. But as Ison approached the sun on November 28th, something went wrong. The comet got too close, and the intense heat and radiation from the sun just ripped it apart. By the time Ison emerged from behind the sun, there was nothing left. It had completely disintegrated. The comet that was supposed to light up the sky just vanished. And Ison is not alone. In the year 2000, a comet called Linear was discovered, and at first it looked like a normal comet with a bright coma and a developing tail. But as it got closer to the sun, observers noticed something strange. The comet started to get dimmer instead of brighter. And then on July 26th, Linear broke apart into at least 12 separate fragments. The comet had literally fallen to pieces under the stress of approaching the sun. And then there was Comet Elenin in 2011. This one sparked all kinds of conspiracy theories about planet alignments and doomsday scenarios. But Elenin never got the chance to do anything catastrophic because it broke apart in August 2011 before it even reached the inner solar system. The comet just couldn't handle the journey. So when we're talking about comets surviving close encounters with the sun, the odds are not in their favor. Most comets that get too close either break apart or evaporate away into nothing. And that's the normal stuff that happens to comets from our own solar system. Comets that formed here and have been making loops around the sun for millions of years. But 3i Atlas is different because it's an interstellar visitor that came from somewhere else, and it's been traveling through the freezing void of space for potentially billions of years. And now, suddenly it's been thrust into the violent environment of our inner solar system and exposed to forces it has never encountered before. The fact that it survived at all is surprising. The fact that it's still in one piece is bordering on impossible. What 3i Atlas survived? Let's talk about what this thing has been through. 3i Atlas was first spotted on July 1st, 2025, when it was still way out in the solar system between the orbits of Mars and Jupiter. At that point, it was already moving fast and already showing signs of unusual activity. By early September, the object was passing through the orbit of Mars, and that's when things started to get really interesting, because the coma around 3i Atlas began forming a tail. But this wasn't a normal comet tail. This tail was pointing toward the sun. We call this an anti-tail, and it's extremely rare because the solar wind normally blows a comet's tail away from the sun. But 3i Atlas was doing the opposite, and nobody could explain why. Then, on October the 29th, 3i Atlas reached Perihelion, which is the closest point to the sun in its orbit. At that time, the object was about 1.4 astronomical units away from the sun. That's somewhere between the orbits of Earth and Mars. Now, that might not sound super close, but you have to remember that this is happening during solar maximum, which is the most active phase of the sun's 11-year cycle. During solar maximum, the sun is covered in sunspots, and it's constantly ejecting massive amounts of radiation and charged particles into space. These coronal mass ejections are powerful enough to disrupt satellites and cause auroras on Earth, and 3i Atlas flew right through all of that. The amount of energy this object absorbed during perihelion was enormous. We're talking about extreme ultraviolet radiation, X-rays, and high-energy particles slamming into the surface of the comet at incredible speeds. This kind of bombardment should have caused the surface to heat up rapidly and start releasing massive amounts of gas and dust. And that's exactly what happened. Observations from late October and early November showed that 3I Atlas was releasing enormous plumes of material into space. The tail grew to millions of kilometers in length. The coma expanded to nearly the size of the sun. This thing was bleeding material at an incredible rate. And here's the thing, when a comet releases that much material that quickly, it creates stress on the internal structure. The outgassing doesn't happen evenly across the surface. It happens in jets that fire out from specific active regions on the nucleus. And those jets create forces that push and pull on the comet in different directions. We call this non-gravitational acceleration because the comet is being moved around by its own outgassing rather than just by gravity. And if those forces are strong enough, or if they're imbalanced in the wrong way, they can literally tear the comet apart from the inside. This is what happened to Linear and Elenin and countless other comets that got too close to the Sun. But 3I Atlas didn't break apart. On October the 29th, when it reached Perihelion, observations showed that the object had experienced a massive increase in brightness and a dramatic surge in outgassing activity. The object was measured to be changing direction by about 200 kilometers per day due to non-gravitational acceleration. That's an enormous amount of force for a comet to withstand. And yet, when astronomers looked at the images of 3I Atlas taken during and after perihelion, they saw something surprising. The nucleus was still intact. There were no signs of fragmentation, no secondary nuclei breaking away, no debris fields spreading out behind it. The comet was holding together, the wobbling jets. And that's when scientists noticed something even more interesting. Between July and September, astronomers had been observing 3I Atlas with telescopes all over the world, and they noticed that the anti-tail pointing toward the sun wasn't static, it was wobbling. The jets of gas shooting out from the nucleus toward the sun would appear and then disappear and then appear again in a very regular pattern. Scientists observed these wobbling jets on 7 specific nights between August 3rd and August 29th. And after analyzing all of the data, they figured out that the jets were wobbling with a period of about 7 hours and 45 minutes. Now, this is important because the wobbling pattern tells us something about what's happening inside the nucleus of the comet. If you have a solid object that's rotating and it has active vents or jets shooting out from specific locations on its surface, then as the object spins, those jets will appear to wobble when viewed from a distance. It's kind of like watching a lighthouse beacon as it rotates. The light appears and disappears in a regular pattern because the lighthouse is spinning. Same concept here. The wobbling jets mean that the nucleus of 3I Atlas is rotating, and by measuring the wobble period, scientists were able to calculate the rotation rate of the nucleus. They determined that the object completes one full rotation every 15.5 hours. And this is the first time that anyone has ever measured the rotation period of an interstellar comet using wobbling jets in an anti-tail. It's a completely new technique, and it only works because 3I Atlas has such unusual behavior. But more importantly, the fact that we can measure a stable rotation period means that the nucleus is solid. It's not a loose collection of fragments tumbling chaotically through space. It's a single coherent object that's spinning on its axis like a planet, and that coherence is what allowed it to survive perihelion. Think about it this way. If 3I Atlas had been a fragile rubble pile held together by weak gravity, the stress from perihelion would have pulled it apart. The intense heating on one side of the object combined with the massive outgassing forces would have created enough torque to break the bonds holding the fragments together. We've seen this happen before with other comets. They get close to the sun and they just fall apart like a sandcastle in the waves. But 3I Atlas didn't do that. Instead, it maintained its structural integrity throughout the entire encounter. The wobbling jets kept firing in their regular pattern. The rotation period stayed consistent. The nucleus stayed in one piece. So why does this matter? Well, for one thing, it tells us that 3I Atlas is not like most comets. The fact that it survived perihelion intact means it must have some kind of internal structure or composition that makes it more resilient than your average dirty snowball. Now, there are a few ways this could happen naturally. One possibility is that the nucleus is made of unusually strong material. We know that 3I Atlas has a very high ratio of carbon dioxide to water compared to normal comets. Most comets are made primarily of water ice, which sublimates and turns into gas at relatively low temperatures. But carbon dioxide ice is different. It's denser, and it sublimates at much lower temperatures, which means it can stay solid further out in the solar system. If the nucleus of 3I Atlas is made primarily of carbon dioxide ice rather than water ice, that could explain why it's been able to hold together so well. The CO2 would create a harder, more rigid structure that's less likely to fracture under stress. It would also explain why the comet started outgassing so early when it was still way out beyond Jupiter. Carbon dioxide sublimates much more easily than water, so you'd expect to see early activity if the nucleus was CO2 rich. And we did see that. The comet was already bright and active when it was first discovered in July, even though it was still 4.5 astronomical units away from the Sun. Another possibility is that the nucleus has some kind of internal layering or stratification that gives it extra strength. Maybe there's a core made of denser material surrounded by layers of ice. Or maybe the object went through some kind of geological processing early in its history that compressed the material and made it more cohesive. We don't really know, because we've never gotten a close-up look at an interstellar comet before. The only other two interstellar objects we've detected, Oumuamua and 2I Borisov, were both too far away for us to study in detail. But 3I Atlas is different because it passed relatively close to several planets in our solar system, which gave us multiple opportunities to observe it with different instruments. And that brings us to the images that were taken by spacecraft in orbit around Mars. On October 3rd, 3I Atlas passed within about 28 million kilometers of Mars, and two European spacecraft, Mars Express and the ExoMars Trace Gas Orbiter, were able to capture images of the comet as it flew by. These images were released in late November, and they showed something that scientists are still trying to understand. The images revealed that 3I Atlas has what they're calling coherence, where dispersion is expected. What that means is that the nucleus appears to have sharp, defined edges and a consistent structure, rather than the fuzzy, diffuse appearance you'd normally see from a cloud of gas and dust. In other words, the object looks solid. It looks like it has physical boundaries and internal structure, and that's not what you'd expect to see if this were just a loose collection of ice and rock being blown apart by solar radiation. A fragmenting comet would show signs of dispersion. You'd see material spreading out. You'd see secondary fragments breaking away. You'd see a chaotic mess. But 3I Atlas doesn't look like that. It looks organized. It looks coherent. It looks like it's holding its shape, despite everything it's been through. The alien question. And this is where things get interesting, because some people are starting to ask whether that coherence could indicate something more than just unusual composition. There's a theory that's been floating around since the beginning that 3I Atlas might not be a natural object at all, and the fact that it's managed to stay intact through perihelion when so many other comets have fallen apart is adding fuel to that theory. Now, before we go too far down this road, let's be clear about something. There is no definitive evidence that 3I Atlas is artificial. Every observation we've made so far can be explained by natural processes: the unusual composition, the anti-tail, the wobbling jets, the coherence. All of it could be the result of this object forming in a very different stellar environment with different materials and different conditions than what we have in our solar system. But here's the thing. If you were going to build a spacecraft that could survive a journey through interstellar space and then pass through the inner solar system to study another star, you'd probably want to make it out of something sturdy. You'd want a structure that could withstand extreme temperature changes, high energy radiation, and the stresses of maneuvering. You'd want something with coherence, something that wouldn't fall apart when things got rough. And if you were trying to disguise that spacecraft as a comet to avoid detection, you might coat it in ice and let it outgas naturally as it approached the sun. You might even program it to wobble in a regular pattern to make it look like it's rotating naturally. Now, I'm not saying that's what 3i Atlas is. I'm just saying that the characteristics we're observing are consistent with an object that was designed to survive, rather than an object that just happened to get lucky. And when you combine the coherence with all of the other weird things about 3i Atlas, the nickel without iron, the extreme negative polarization, the anti-tail that shouldn't exist, the timing of its arrival during solar maximum, the fact that it came from the thick disk of the galaxy, which is full of ancient stars, it starts to feel like there are too many coincidences. Avi Loeb, the Harvard astrophysicist who's been studying 3i Atlas since it was discovered, has pointed out that the object's trajectory brought it close to Mars, Venus, and Jupiter, but it missed Earth entirely. We were on the opposite side of the Sun when 3i Atlas made its closest approach. Some people think that's just random chance, but if this were a reconnaissance mission from an advanced civilization, you might program your probe to get close enough to observe the planets, but not so close that you'd risk detection by the one planet that has intelligent life and active space programs. You'd want to stay hidden, you'd want to observe from a distance, and you'd want to make sure your probe was tough enough to survive the journey. What happens next? So here's where we are. 3i Atlas survived perihelion against all odds. It's still in one piece. It's still outgassing. It's still moving through the solar system, and it's heading out. On March 16th, 2026, the object will fly past Jupiter at a distance of about 53 million kilometers. That will be our last good opportunity to observe it before it leaves the inner solar system and heads back out into interstellar space. There's a spacecraft orbiting Jupiter called Juno, and there's been some discussion about whether NASA could redirect it to intercept 3i Atlas and get a close-up look at the nucleus. That mission is technically possible, but it would require NASA to make a decision soon, because once 3i Atlas passes Jupiter, it's gone. By late 2026, it will be beyond Neptune. By 2027, it will be in the outer reaches of the solar system, heading back to wherever it came from. And if we let it go without studying it up close, we might never get another chance to answer these questions. Was this just an unusually tough comet that got lucky? Or was it something more? The coherence suggests it's special. The survival suggests it's resilient. The timing suggests it might have been intentional. But we won't know for sure unless we chase it down. And right now, scientists are racing against the clock to figure out if that's even possible. Because in the world of space exploration, once something is gone, it's gone forever. And 3i Atlas is not coming back.